Okay, so we are going to talk about elasticities and how to measure them. And specifically, what we're really going to focus on are estimating these things using some linear regression models. So with that said, I'm going to post some more technical types of paperwork. So I'm looking at one here. There's a lot of them out on the web. If they look too technical and it gets in your way, just absolutely, you can totally ignore it. What I do want to show you is how to use these things and show you the key functions or the key formulas that you really just need to know and try to put some sense into them. I'm going to just do a little bit of math to try to, because I think sometimes math, when I play with the numbers a little bit, help you kind of see how some formulas relate. And let's get started. So elasticity, the key equation that we're going to look at is really this equation when we're looking at equation 3 here. So you see elasticity, it's really just going to be defined as this change in y. That's a change in quantity, percentage change. That's a big difference, percentage change for a given percentage change in price. So to the right, you'll see this delta, that's a change, delta y over delta p times p over y. That's the formula we're going to use, and I'm just going to demystify this a little bit right now and then show you exactly how this relates to different types of regression models. So first off, I want to just take a moment and just let us think about percentages. So if I was going to calculate, say you started at 100 and you go to 105, okay, so what would that look like? What's the percent? Well, clearly that's 5%. Think about it. How'd you do it? Well, you went 105 minus 100, parenthesis divided by, maybe 100 would be like an estimate, right? You could estimate it like this. That would give you, this would give you a 5% if I multiply it by 100, say 5%. Okay, there you go. That's your intuition. Let's see how this relates. Okay, so this equation that we have here for this elasticity, we have this percentage. So this is going to be defined as this percentage change in quantity over a percentage change in price. Now, notationally, I want you to notice that your book is using Q is this dp. That's a d. It's a function. If I zoom in real closely, it says d function of p is going to be represented by q. That's because we're talking about, your book's talking about price response functions. So remember, what's a function? Y is a function of x. What does that mean? That means you give me an x and it'll give you a y, right? And what we're talking about in this case is we're talking about quantity is a function, and they say a d of p. It means give me a price, and this function is going to tell you how much quantity demanded will be. This is a demand response, this price response function, right? This is notationally in your book. So let's stick to the elasticity, and instead of saying dq, let's write this percentage change in d of p. It's just a function of p. So this is our quantity for this percentage change in price. Okay, now that is starting to kind of look like this equation. Actually, the key equation in your book, I will show you for elasticity. The one that I'm going to relate this to is I'm going to relate this to equation 3.8 on page 52 of your Phillips book, Pricing and Revenue Optimization, and I'm relating that to equation 3 here in the paper. So, so in this paper here, you see I have an equation which is going to be this percentage change of dp over p. Looking back on, it's going to be actually defined as delta y, which is going to be d of p, right? D of p over delta p times p over y. That's what you see on equation 3 right here on the screen. And it looks a little bit different than your book on first inspection. When some of you, especially if you don't know calculus, you'll see, if you look, please look at equation 3.8. So this is in the paper. This is your paper. And in the book, we have this d prime of p times p over d of p. Okay, so let's see, just relating this. Actually, if you don't know calculus, this is actually a derivative. A derivative means a change. A change is represented by a delta. What is d prime of p? Well, actually, really, d prime of p is just going to be defined as delta d of p over for a change in p. So this is how d of p is changing with respect to p, you see? And if we just do the substitution directly, so if d prime of p is equal to delta d of p over delta p, right here, if I just substitute this in, then you see that these two equations are exactly the same thing. So these are exactly the same equations. Your book writes it using a derivative. Actually, you may be a little more comfortable just looking at it straight here. And so that's the first thing, is I wanted to show you how the book and this paper, how these relate, is that, but the key thing that we're having here, look, the key thing that's nice about your book is that this term, this d prime of p, okay, this is actually going to be the slope of our price response function. So when we have our price response function, we're looking at the slope of it. You see? The slope of it's right here. Now, what is this p over d of p? These are going to be specific quantities. So just to put this in a real context, okay, if I have a price response function, okay, that means price response function is meaning that q is a d, it's a function of p. So that means I'm going to have q up here, which will go at q equals d of p on the y-axis. So q, quantity function of p, we'll put p down here. And if I were to go look at different data points, maybe for this price, I don't know, whatever it is, would be corresponding to such and such quantity, and you can plot out different points, right, and come up with a scatter plot that then you can fit a linear regression model on. So linear regression model is finding the line that best characterizes this data, okay? And then the slope of that line, the rise of the run, the change. So what is it? Rise over run. The change in the height for the change in the run. The change in the height is this change in the height is a change in Q or a change in D of P. And the run is a change in P, right? Change in P. So therefore we have the slope is equal, rise over run. It's this delta D of P over delta P. That's the slope of our price response function. And what did I tell you? I told you that there it is, right there. Also equivalently written as d prime of p, if you want to, in your book, okay? So the nice thing is we can estimate this thing just very directly using Tableau or some other type of statistical software, and then calculate elasticities, okay, just very directly. So I want to do that. That's actually what we're going to do here next. But before we get there, there's something I left in the beginning of the talk, and I want to circle back to it, and then we'll continue on to actually looking at this and showing you how to estimate this. Okay, but what I want to do is show you first, we start off with this, percentage equation intuition. So how does this relate? Okay, I want to just come back. I think I left that in the dust, and I want to just come back and tie that up nice and neat. So here we go. Look, I showed you. If we went from 100 to 105, we know it's 5%. Look, if I just do this change from 100, this is a delta, right, on the top. And this down here is a number. This is a relative number. So I'll say that this is, let's just say that this is a change in price. Okay, so this would be a delta P on the top, and down below would just be a price for a given, starting from a given price. Okay, look what we have here. A delta, say this is, so these are prices. 105 goes from 100 to 105. What's the percentage? It's 5% change in price. How do we get that? Look, it was the change in this P over this initial P. That's kind of one way to look at it. Very simply, now let's think about this. If we wanted to talk about elasticity, this change in Q, this percentage change in Q, okay? So let's just use the same logic up here. What would this be? This percentage change of Q, okay, would be this change in Q over a Q, right? right, on the top, this percentage change in Q, and this is divided by a percentage change of P. What is that? That's a change in P over P. We'll just write it like that. Well, hey, look, do you know that, so again, look, there's a lot of division here. There's a fraction on the top. There's a fraction on the bottom. How to make sense? Look, do you remember some basic maths? If you divide by a fraction, you multiply by the reciprocal. So let's just multiply delta Q over Q by the reciprocal of this denominator, and we see the reciprocal. So this is going to be, I'm running out of room and I'm working backwards, but this would be actually, and I can keep kind of going over here on this paper, this would be so this delta Q over Q on the numerator times, so instead of dividing by a fraction, let's multiply by the reciprocal. This would be multiplied by the reciprocal. So P on the top now, P over delta P, okay? And now, do you see how this is starting to look very familiar to our elasticity? Actually, is exactly that, because remember, Q is equal to D of P. So we can rewrite this equation in terms of our book to keep notation straight. And Q, we'll write this change in D of P, which is the same as writing Q, over D of P times P over delta P. I just rewrote this equation. And when we just organize our deltas, stack them on top, we get a delta D of P over delta P, which is the slope, again, reminding ourselves, that's the slope of our price response function. Now, times, what do we have here? P, just moving this over D of P, just like that. Look at that. And this is our elasticity. So I'm just trying to show you how the maths all relate so that they don't seem so esoteric and just so just it can seem a little convoluted. And I wanted to show you, and the notations are different. You got DOP, you got Qs, you got derivatives, you got some deltas, you got all these things. I'm trying to just show you how all they relate. And then we're talking about percentages. And so how does this all relate to percentages? Okay. Hopefully now, watch it again if it's not clear. I hope that it clarified some of the notation and just cleared things up. Okay. This I have to say, okay, so now I want to go actually back to how to estimate these things. Now, we talked about the slope of the price response function and being this, and this is our interpretation here, okay? This is going to be our interpretation if we have levels of quantity and levels of prices. What do I mean by levels? I mean just raw numbers, like, however much quantity it is, however much the price is, that's the level of quantity, level of price. That's what I'm talking about now. I'm going to show you a nifty way to transform this so we can skip some steps and make it a little easier. We'll do that later. Let's walk through the levels just in raw levels. We'll work with it first this way, okay? So first, let's look at estimating this now using Tableau. I think that's the best way instead of me writing a bunch of little dots on a piece of paper. What I'm going to do is take a look at the soda demand sheet. So again, this sheet that I'm going to have is soda.csv. It's in your online resources, and you're going to have a product. You're going to have an assignment that's concerning this. So stay tuned on this and take a look at this. Download it, put it in your Tableau, and follow along. It's probably the best way for you to learn instead of just watching me. Right now, I would recommend pausing the video, get your Tableau open, get CSV or get soda.csv loaded in your Tableau, and then follow. That's my recommendation. Okay, 3, go ahead and pause. 2, you can go ahead and pause and up to it. 1, okay, welcome back. Okay, so here we go. Look, we're going to go, and after I've uploaded the data, it's a pretty clean set. I use the data interpreter actually to load it in. And then I'm going to just, so first off, let's think about a price response function. I need quantities here on the Y. I need prices up there. Okay, so where's quantities? Whoa, did I miss it? Oh, there's quantity right there. Got it. And prices. Let's see, just toss it in the rows. There we go. Okay, that's a singular metric. Why is it singular? Well, because, look, this is a summation. So first off, we need to take a very close consideration of our measurement here in Tableau. Notice that it's a sum of prices. It's adding everything up together to a single number. So what we need to do, first off, that doesn't really make sense, does it? If you have a bunch of sales, if you looked at this data set, you should know that this data set, we should look at the data source real quick and see that this is actually soda sales for different brands of cola in different containers, and we get price and quantity, and we've got different shops in different cities on different dates. So thinking about that, it doesn't make a lot of sense to just add up all the prices. So if you have like a list of all these different sales, does it make sense to add, prices together? It doesn't make any sense, right? So let's think. Probably we need to change our measure. Measurement. Let's go to with an average. Average price. Okay, that feels a little better. Can we add up our quantities? Sure, you bet we can, because quantities are the number of sales that we have, right? We want to not average. Hopefully, you understand the difference of why we wanted the average price and not some quantities. If not, think about it a little bit. Send me a question. I'm happy to clear that up. Okay, so keep on going now. Why do we just have a dot? Why? Because this is for the whole data set. So we want to narrow in scope a little bit. First off, let's go ahead and change some of our marks. Let's go ahead and change some of our marks. The details on this. So remember, this is over time. So let's do this over time. What do we need? We need a date measure. Get a date, drag it in the details. Now we're starting to see some scatter. Now years, this is interesting. If we go year, we'll just do, you see how many years we have? Look, we got these different years. This is for each year. But actually, it goes a lot more detailed than that. This goes down to the month level. How to get that? If I do month, then I'll get 12 measures because it's for every single month, you see? Actually, that's not quite what I want either. What I really want is, when I look on the right here, the grayed out, I want the month and year. Let's go like that. Oh, now we're starting to get it. Now we're starting to get to the detail level we want. So on our marks, we want to drag in the date and then select month, year. And remember, this is for a bunch of different brands and a bunch of different container types. So right now the data, this scatter is fairly nonsensical. So let's use our filter and say get down to a certain container type. And it doesn't really matter at this point. I'm just going to go ahead and pick, what do you want to pick? Glass, can, plastic. Let's go ahead and pick some cans, okay? Yeah, sure. Cans are kind of old school. Pick some cans. And we also have brands in here, right? So we have brands and we also have city locations. So first off, let's go brand, and say pull this. Should we do all brands? No, we'll just pick what brand we want. Filter. Let's go with good old Gazoza. Yeah, it's a good one. Sure. Hey, look, now our scatter plot is starting to take that nice familiar downward. You see it has got a downward correlation. And this is, when we fit a line, is going to be what we can use to just sort of approximate our price response function. Okay, great. This is starting to look good. What am I doing here? Look, how am I going to get that regression line in? How do I get a regression line in Tableau? Very simple. Analytics. So here's data. Here's analytics. Trend line. Bam. Done. Wait a second. What's the slope of that thing? Oh, just hover over it. It's pretty big. Negative 1.05. That doesn't look big, but look, there's an e to the power of 6. Oh, geez, we gotta move some decimal places on that. That's some scientific notation that's out there. That's pretty big. Okay, so there we go. It's a little bit big, but that's okay. That's okay. That's just what it is. Okay. Let's see. One thing I could do now. Look, remember, we also have location. So let's go ahead and just play this a little bit more, make it a little more interesting. How about we go grab city, this is our location, look at it, plop it up there. Hey, look at this. Now I have it for every different market. That's very interesting now, because when I'm calculating, so if for a given price, we can calculate the elasticities then for different markets. This is starting to look cool. Okay, I can see, what's the slope here? It's negative 2,859. It's negative 1,006. Okay, this is starting to actually look like we're getting somewhere where we need to be. I think this is looking a lot better. So really clearly, I want to just hit one point to you all. That's this. You're talking about economics, you're talking about microeconomics, you're talking about markets, right? So whatever it is, make sure you really do pin down the market that I think on the most granular level that you can, while still having the data variation that you need to make the analysis. So in this case, the market for just say cans of gazosa, it's kind of a little bit nonsensical to think about the market on a country level. I mean, just think about like any brand that you want to think of, like in the United States. It's a little bit nonsensical to think of like U.S. demand and think about elasticity and trying to make price decisions. Why? Because there's so much geographic variation, right? Like if you're in one part of the country, it's completely different than another part as far as preferences, as far as all kinds of different things that define a local geographic market. Okay, even say like in Colombia, okay, would it make sense to think about downtown Colombia and think about if we were to be out in Greenwood? Those are different markets. I'd expect there actually to be different demands with different elasticities. And if I had the data and if I was really inclined, I would be very much pushing for trying to get down to that kind of level. You want to get to the market level. You know, you're making price decisions, so make sure that your model is going to be at the level of aggregation, the level that describes the market that you really care about. Or else you might get something kind of nonsensical and make some kind of weird, strange decisions based on that very advanced, methodology. Methodology won't get you there alone. Okay, you got to really think about the market. You got to put your business hats on. Okay, so here we go. Look at this. We got this going. I'm going to show you how to calculate the point elasticity now of demand. Okay, so now let's look at the point elasticity. This is going to be cool. Look, point elasticity of demand. Okay, so the cool thing is that we're going to calculate the elasticity at a point. And elasticity, remember, is going to change over the entire schedule. So let's take a look at this. What you need to calculate, and this was the formula that we've been kicking around right over here. Look, this one right here. That's the formula that we're going to use to calculate this point elasticity. So what do we have here? Look, we have the slope. Now all we need is a point. A point on this scatter plot. Look down here on the, I want to see the math and I want to see the actual application. A point is defined by a price quantity pair. So for this particular point with my little hands over, I have a price of 0.22 and I have a quantity of 142,000. You see, a price quantity pair defines that point, and also I have a slope. You see, I have a slope and I have a price, I have a quantity. Can you calculate elasticity? Yes, you can. I hope you can. Okay, so let's grab it. Let's go ahead and just grab a point here. Say, let's grab it for Larissa, the city of Larissa, and this will be for gazosa cans in the city of Larissa. I'll be asking you to do some of these types of things and then interpret it. Okay, so let's walk you through the actual calculation. So for the city of Larissa, okay, what is this point? The point, so the price here that I'm looking at, let's just pull a price of, say the price is equal to, say, what is this, 0.27, okay? So if you're at price 0.27 and you have quantity is equal to 32,930, okay? Then I'm pulling that point. What do I think my point elasticity is? What's my estimated point elasticity? And of course, this is going to be with error because you see this line doesn't quite fit right on those points, and that's fine. But with error, our elasticity, we're going to calculate it from the data points that we actually have. And we have this P, we have this Q. Remember, the slope is this delta Q over this delta P. Oh, and I see I got off my notation. Remember, Q, this is going to be this D of P to keep your book. And this is going to be this delta D of P over delta P. And elasticity is remember, elasticity is going to be defined as this times P over Q. Just something very simple like that. Very simple to remember. Just if you know the slope, then just flip these guys around and throw them in there in levels, and you got it, okay? So times P over Q. Can you do this? This is going, what's the slope? Slope is, grab it. Slope is going to be, it's negative. Always, we're just going to omit the negative and write the number. It's 1,67218. That is my slope times my P over Q times P. So I'm going to do times with a dot notation. Times P is 0.27 over Q, 32,930. Bada bing, bada boom. I'm going to leave you to put that into your calculator. I don't feel like doing it, to be honest. Don't call me lazy. I just don't want to put it in. You can calculate this, okay? This is 167,216 times this fraction. Okay? Bada bing, bada boom. There's your elasticity for that point. Now, with the elasticity at that point, remember, elasticity of demand, we're going to start to make managerial decisions. And this is where you need to go back and watch the videos. And I'm not going to put it here, but just remember to remind ourselves, if the elasticity is greater than 1, remember elasticity being defined as this percentage change in quantity for this percentage change in price. Look, the only way this can be greater than 1 is if the quantity effect dominates, okay? So remember, this is how you logic it. Total revenue is equal to price times quantity, right? So when I raise my prices, I get more revenue from higher prices, but because demand's downward sloping, I get less quantity. So if I raise prices, there's a positive revenue effect and a negative quantity effect. And then the question is, which one dominates? Can you answer that? If I raise prices here, what's going to happen to my revenues? Okay, pause it. Do not listen to me give you the answer. Work this question out. Don't cheat yourself. I want an answer. What's going to happen to my revenues, folks? No, actually, you know what? We need to calculate this thing. Let's get back to this. Okay, shoot, I didn't want to calculate it because I am kind of lazy about that, I'll be honest. But let's go ahead and calculate it. Come on, here we go. We'll go ahead and calculate it right here on my phone, okay? So let's just do this. 1,67216 times 0.27 equals divided by 32930 equals 1.37 and some change estimated, okay? 1.37, we'll call it right there. Elasticity of 1.37, folks. First off, is it elastic or inelastic? It's elastic. Okay, so elastic. It is greater than 1. We're on the right track. Okay, I was just lucky and guessed that. So look, if the price goes up, if we jack up our prices, look, we're going to get more revenue from price, less from quantity. Look, for this to be great, for this elasticity metric to be greater than 1, that means quantity effect dominates. What's the quantity effect when I raise my prices? It's negative. What's the so here's my effects on revenue. Raise price, negative quantity effect over, there's this positive on the price effect, but quantity effect dominates. Therefore, not a good idea. We're going to lose money, at least in revenue. We're going to talk about profits later, but revenue-wise, not the best move, okay? So revenue-wise, when you raise your price, you got elastic demand. That means quantity effect's going to dominate. You're going to shoot yourself in the foot for the revenue. So somebody comes and says, raise the price. No, price optimization means you should probably, if you're really just trying to optimize revenues, then if it's revenues all you care about, then we need to drop our price in order to make revenue go up. That's the scoop of it, okay? Bam. Cool thing I want to show you, okay? So there it is. That is my worked example. Boom. Now I want to show you really quickly something else. Look at this. Okay, look. If I go now, let's say I want to take a study. So we could actually look at, for a given price, we could actually look at different elasticities and look at the elasticities across cities. Just looking at slopes. What is that? Negative 285, like 167. Slope won't tell you the whole thing because remember, this is going to change for a given price and point. But if we have some overlap, then we can kind of look and see which market the price is more or less elastic. And it gets the point that, if you're optimizing revenues, you're not going to want to just go across the board with price changes. You're going to want to probably do it market by market if you can, and try to optimize your revenues in each of these markets. Okay, that's a better approach. And you can kind of tell which markets are more or less elastic looking across geographies. And that's kind of cool. So look, as it becomes, generally speaking, remember, slope is not elasticity, but as the slope of this demand curve becomes more flat, okay, the demand becomes more elastic. When it becomes more vertical, it becomes more inelastic, okay, for a given point. Now, all things considered equal, okay, all things held constant. Now, with that said, so you can kind of look, one thing that's kind of interesting is I can now look across geographies. And what's the other dimension of variation? Time. I have geography and time. So cool beans. Let's look at this. What if I dropped date right in the rows column? Now I got years, and I can look at, for a city, how the elasticity of a product might change over time. Then seems like it's changing a whole bunch here, maybe a little bit. I don't know. I'll leave it up to you. There is also statistical variation here. We're not fully accounting for that, but sometimes just looking at it with your eye, you can see, for example, that in Petra, I'm not Greek, but looks like that's quite a big change. It became maybe much more elastic. Okay, meaning that generally, as goods become more elastic, that's a sign of more competitive environments. Maybe perhaps in Patra, there was something going on there, such as if you have more substitutes to get introduced to the market, say like a new type of cola that people are really just kind of jumping on, besides this Guzoza, it's a rival, it's a substitute, and these are entering the market and they're maybe catching on in Patra. So if I saw this, the manager might think, what's happening in Patra in 2015? Maybe if this was new data, say it was in 14, where we see this nice inelastic, means we've got a nice competitive edge, and all of a sudden we get more elastic demand. Hey, I'm going to start thinking, what's happening here? Are there more substitutes? Why are we seeing this? Or is this just a statistical anomaly? Those are the kind of questions. You see the same thing over here in Athens in 2014. There was this move. So looking at 13 to 14, became more elastic, then kind of went back. Interesting. You can see elasticity variation across time, across geography. These are the kinds of things that are going to give you some deeper kind of insights and kind of give you the directions as to where to explore what's going on here. This isn't going to give you all the answers. This is just sort of like the end result of what happened, and it's not causal either. Remember, we're going to get into that later. So there's some statistical challenges here too we haven't dealt with. We're sweeping under the rug. But in general, this elasticity sort of exercise will definitely help you to give you some direction as to what might be a profitable or curious line of questioning in terms of narrowing in your scope of questioning. For example, narrowing it in, saying, okay, Patra, what's going on with your Gazoza can sales 2015? What happened here? What's going on? Be curious. Curiosity, it's not what kills the cat. It's what puts money in the bag when it comes to data science and analytics. Okay, so enjoy that. I hope you did. And this is a great primer for your project. It's intended to be a primer for your project. If you have any questions, feel free to reach out. I do recommend that you walk through this video with your hands on the keyboard, and that should get you right in prime shape to do great on your project.